In this evidence, we're going to talk about how we use the numerical methods nowadays. First of all, we're going to give you a brief introduction, so let's start. Numerical analysis, area of mathematics and computer science that creates, analyzes, and implements algorithms for obtaining numerical solutions to problems involving continuous variables. Such problems arise throughout the natural sciences, social sciences, engineering, medicine, and business. Since the mid-20th century, growth in power and availability of digital computers has led to an increasing use of realistic mathematical models. In science and engineering, and numerical analysis of increasing sophistication is needed to solve these more detailed models of the world. The formal academic area of numerical analysis ranges from quite theoretical mathematical studies to computer science issues. With increasing availability of computer, the new discipline of scientific computer or computational science emerged during the 1980s and 1990s. The discipline combines numerical analysis, symbolic mathematical computations, computer graphics, and other areas of computer science to make it easier to set up, solve, and interpret complicated mathematical models of the real world. Numerical analysis is concerned with all aspects of the numerical solution of a problem, from the theoretical development and understanding of numerical methods to their practical implementation as reliable of efficient computer programs. Most numerical analysts specialize in small subfields, but they share some common concerns, perspectives, and mathematical methods of analysis.
Classical mathematics still in the hearts of the most ingenious mathematics with which you can all solve this problem with the level that today technology records. These consequences have made numerical methods displace the classical numerical analysis of research applications in different industries. Also in the part of the analytical approach, they are not so considered, but when the most common way I needed strong numerical methods since we are a little more economical apart. Programs and the ease of being able to use them can be available. This can lead use the conclusions that a model is a set of hypotheses about some behavior or operations in a system attached to really and normally those that are bases or universal principles and lags are those that are represented in mathematical equations. Example: Maxwell's equations for the electromagnetic fields, Navier-Stokes equation that describe the motion of the ball subject to external forces, etc. It's very common that mathematical models are used for the design of process to make simulations and obtain results at scale. An example could be parameters such as temperature or speed. This serves in order to improve process or products in the industry without having to have very excessive costs.
One very good example of the application of numerical methods is the computer-aided engineering, or CAE, which is a very important subject within engineering. One important CAE topic is the modeling of the dynamics of moving mechanical systems, a technique that involves both ordinary differential equations and algebraic equations. The numerical analysis of these mixed systems, called differential algebraic systems, is quite difficult, but necessary in order to model moving mechanical systems. Building simulations for cars, planes, and other vehicles require the solving of very complex differential algebraic systems in real time. Another important application is atmospheric modeling. In addition to improving weather forecasts, such models are crucial for the understanding of human effects on Earth's climate. In order to create a useful model, many variables must be introduced. Fundamental among these are the velocity, pressure, temperature, all given positions, and time t. In addition, various chemicals exist in the atmosphere, including ozone, certain chemical pollutants, carbon dioxide, and other gases and particles, and their interactions have to be considered. The underlying equations for studying are partial differential equations, and the interaction of various chemicals as described using some quite difficult ordinary differential equations. For our last example, modern businesses rely on optimization methods to decide how to allocate resources more efficiently. For example, optimization methods are used for inventory control, scheduling, determining the best location for manufacturing, and storage facilities. All of this is accomplished with extremely high-power software that has to be reliable, accurate, and efficient. The most popular languages for programming numerical methods are C, C++, and Java.